Okay, Assalamualaikum. So in this video, I'm gonna explain about the pre-lab tree, which is the last pre-lab. So the topic is extractions of acetone from water using the toluene. So this is the lab of liquid extraction theory. So this pre-lab is prepared by me, Kasrina Jazwani binti Rostam. Okay, so let's get started. So the first one is theory. So as we have learned before, separation from liquid extraction can be defined as the selective removal of one or more solutes, either from a homogeneous mixture or from solution. So if we want to extract, we have to use the liquid that we call it as solvent. So the solvent is partially immiscible, or what we call it as insoluble, with the first mixture, which is the feed. So in the process, the feed mixture or solution is mixed with the solvent in an agitated vessel. So after a certain time, the extract stream contains little of solvent, but actually high purity in solutes, as the solutes in the solution has been absorbed to the solvent, or what we call as being extract to the solvent. So finally, the raffinate stream contains same components as the feed stream, but actually it is different of max fraction or composition. So usually raffinate stream have a much lower solute concentration, but actually high concentrations of diluent and maybe a little bit of solvent. So the objective of this process is the first one, to operate a liquid extraction experiment using rotating this column. So the second one, to determine the high equivalent theoretical plates, which is HETP, for the column. And the last one is to investigate the effect of the solvent to the feed flow rates. So this is what we call a process flow diagram, or PFD. So the first one is feed vessels, which is B1. So this is B1 and B2. So these two vessels actually contains of feed, which is solvent and solvents and mixture, or what we call it as solution. So the second part is the rotating this column. So this tall equipment is called as rotating this column. So in the process, the feed from these two vessels will flow into the rotating this column. So the effective height of this column is actually 2 meters. So the next part is dosing pumps. Dosing pumps, which is P1 and P2. So these two pumps are actually operate to increase the flow rates or the velocity of the feed from these two vessels. So another part is receiving vessels. So receiving vessels is B3 and B4. So after the process in the rotating this column is done, so the raffinate samples and the extract samples being collected or being flowed into the B3 and B4 vessels, which is what we call it as receiving vessels. So pulsation, so the last part is rotating this stirrer. So actually in this rotating this column, it has a rotating this stirrer. So the function of the stirrer is to stir the solvent and the mix perfect the mixture and the solvent. The stirrer is a function to well mix the both solution or both liquids. So this is the PFT. So the next part is the procedures. Okay. The first one, to ensure that all we have to ensure that all equilibrium and calibration data are obtained. So the second part, we have to perform the general startup procedures first. Okay, the next part, we have to start both pumps, which is P1 and P2, and set the desired feed and solvent flow rates by adjusting the pump frequencies and the displacement. So after that, we have to allow both liquids to flow into the collection vessels B3 and B4 respectively. The bottom product contains water-rich phase, while the top product contains the toluene-rich phase. So after that, we have to monitor the interface level, maintain it at about 100 centimeter above the solvent inlet by adjusting the height of the overflow. So once both collections vessels B3 and B4 are filled with the sample products, so we can start to collect the samples. Open valve HV17 to collect the sample of raffinates, and another valve which is HV15 to collect the samples of extract. So number 8, we can start the stopwatch and continue to collect the product samples at every 2, 4, 6 minutes until refractive index, which is Ri, value are constant. So next, we can record the refractive index values of both samples until constant and use the calibration curves to determine the acetone composition in each phase. Then we can record all the data in the sample table. So after that, stop both pump P1 and P2. So the last one, or finally, we have to repeat the experiment, which is step 3 until step 10 by turning on the rotating disc stirrer and set the strip stirrer speed at 250 rotating per minute RPM, but fix the same flow rate and feed composition throughout the whole experiment. So actually we have to calculate, or we have to do some missing if we have to do the calculation, but we have to know what is the data is missing in this experiment. So there are some missing data that is being searched in this experiment. So the first one is mass fraction, which is what we call it as weight percent. So the second one is theoretical stages. Third one is high equivalent theoretical plates, HETP, and the last one is efficiency. So this is the calculation or the formula to calculate the missing data. So the first one is mass fraction. So we have to getting the volume and um, multiply it by the density and divided it by the total mass. So for high equivalent theoretical plates HETP, we have to get the effective column height divided by the number of theoretical stages. So the last one for the efficiency, we have to get the extract flow rate, multiply it by extract composition and divided them by the feed flow rate, multiplied by the feed composition. So after we run the experiment, there are some expected results that we can obtain. So the first one, we can determine the high equivalent theoretical plates, which is HETP. We also can determine the efficiency for different solvent to feed ratios and rotating this. And the last one, you also can investigate the effect of the solvent and feed to flow rates. So, and that's all for me. Thank you.